actually on the foldable, we're going to do the last three letters, the ing. So we're going to start with this thing called the sum of two cubes. And even though your phone gets a little blurry, it should say a cubed plus b cubed right here. And somewhere in there, you need to write down this formula. This may be a new one for you. Depending on who you had in Algebra 1B, you may not have ever seen this before. And if you have the sum of two cubes, here is the formula for that. Any of you who did learn this, did any of you learn the SOAP business? You know what that means, S-O-A-P? Let me kind of tell you what that is. You'll take it with you. Notice that when you have a sum of two perfect cubes, you have a binomial times a trinomial. Always. Binomial times a trinomial. This binomial is always the cube root of the two numbers. Cube root of A is A, cube root of B is B, and then A squared. This will be the product of A and B, and this is B squared. Where the SOAP comes in is your signs, because kids have trouble remembering, is it a plus, a minus, a plus, where's the minus, where's that? So S in SOAP stands for same, meaning whatever you have in your original problem, since it's a plus, and your first one here is going to be same, opposite, and then always positive. So same is the same as the problem itself, opposite, always positive. So this is how it works. Let's say we have 8 cubed, x cubed plus 8. Now cube, your brain is going to have a hard time because at first you're going to think, oh, 8's not anything special, but it is. It's a perfect cube because 2 times 2 times 2 is 8. So the first thing I need to do is write both of these as something cubed. This guy is already x cubed, we're good with that. But now I'm going to write 8 as 2 cubed. And I need to put in that step because now I see that my A is x, my B is 2. The B is not 8, it's the cube root of 8. So then I'll set up my two parentheses for a binomial and trinomial. I'll SOAP, if you will. So S is the same as the original problem in here. Opposite, always positive. SOAP it there. And then these two numbers will just be the x and the 2. This first number is the x squared. The last number is the 2 squared. And then the middle is the product of 2 times x, which is 2x. So those are the two factors of this perfect cube binomial. And again, believe it or not, if I were to multiply that out, with that binomial, if I were to distribute this x 3 times, and then the 2 3 times, I'd end up at x cubed plus 8. But not only do we have sum of cubes, but we also have difference of cubes. Notice it's the very same formula, just with a bunch of signs that are different. But actually, we're still going to apply SOAP. All right, so again, let's notice this one is the difference of two cubes, so it's a subtraction problem, the original. So again, it's a binomial times a trinomial. We've set up the signs with our SOAP. This first one is the same as the original problem, and then the opposite, and then always positive. And then the pattern's exactly the same as for sum of two cubes. Some no difference, the same except sign different. So how does this one work? The very same way. Let's say we have 8x cubed minus 1. 8 should start sticking out in your mind as a cubic. That's a perfect cube. So let's first write it as two things cubed. So I'm going to write this first one as 2x cubed, because that would give me 8x cubed, minus 1 cubed. And this is probably the most crucial step, the one that kids tend to leave out. So in this case, what's my a? What's my a? 2x, the whole thing, yeah. And what's my b? Okay. So binomial times trinomial. We're going to soap it. So the same, opposite, always positive. I'm going to write in the 2x and the 1. First term in my trinomial will be that a, that 2x squared, which would give me 4x squared. And then the last term will be that 1 squared, which is still just 1. And then the middle term is the product of 2x times 1, which is 2x. So those are the two factors of that binomial. Okay. All right, let's do one more together, and then I'm going to have you do a couple on your own. Z cubed minus 125. Tell you what, the first thing we need to do is we need to find the cube button on your calculator. Let's pause a minute. Now, what if you have something like this, where you have x cubed plus 64y cubed? Again, finding what is a and what is b is the big deal. So x cubed is already ready to go. So I know my a is going to be x. How about this guy? Cube root of 64, 4, and the cube root of y, so it's 4y cubed. We're going to finish that one off for us. And now? Yes, sir. I do want to show you just one time how it really does check out, because right now, since this is the first time y'all have ever seen it, I do want to show you one time. I'm going to show you that if I multiply this binomial times this trinomial, I'll end up right back here. I'm going to prove it to you once, okay? I'm going to double distribute, so the z times z squared is z to the third. Z times 5z is 5z squared. Z times 25 is 25z. Then distribute the negative 5. Negative 5 there is negative 5z squared. That would be negative 25z and negative 125. Add those together. These cancel, I'm left with here minus 125. So it really does. Yes, ma'am.
I have a question on the right.
All right, what if we have one like this? Now at this point, I would suggest that you use your foldable every time you factor and start with the very first window. Because what does the first window tell me always to try to do? GCF. And this is one of those cases. What can I pull out of a 54 and a 2? 2. That leaves me with 27x cubed minus 1. Now I recognize, oh, this is a cube, difference of cubes. Now, 2 is still part of my solution, part of my factoring. I've got to keep the 2 in there. So keep the 2 there. I'm going to write this as something, let's see, this would be what, 3x cubed, that's my a. And this would be 1 cubed. So again, keep my 2 there. Binomial times a trinomial. Soap it. Same, opposite, always positive. That's 1. 9x squared, 1 squared. Probably 2. So I need 3 factors when I'm done. Can't leave that 2 out. Because whatever it is here has to be able to multiply out to back here. And if you leave that 2 off, you will not end up back there. It has to be part of your factory. No, maybe not. Now, we look at that and we freak out, right? I don't know about you, but I do. But now we're gonna stop and we're gonna take a deep breath, we're gonna look at our foldable, and we're gonna say, oh, GCF. What can I pull out of an 81 y to the 4th and 192? Basically the 81 and the 192. Does the 81 come out of there? No. Okay, y'all just keep trying a minute. Okay, let's move on. This is your quads in disguise. This is your last window on your foldable. Quads in disguise. What do you think quad stands for? You would think so. This is abbreviation for quadratics. Yeah. It's abbreviation from quadratics. And with quadratics, that's all the stuff we did yesterday with Mark and Martin. Those were all quadratic trinomials, most of them. We did have a few that were bigger that we had to pull something out first, but most of them were quadratics. So when I look at this, it kind of looks like the trinomials we had yesterday, because are there factors of 6 that add up to -5? There are. -6 and 1, right? Okay, so what if I, in place of this, I mean, I went on to, okay, so first of all, would this be a mini mark or a mark? Mini mark, because nothing's in front of you, right? So on mini marks, I'd go on and start with my grouping, right? And I would put a -6 and a +1. But here and here, how am I going to end up with an x to the 6? Oh, see, I told you that work. We talked about it yesterday. Yeah, because -6 times 1 doesn't equal 6. Thank you very much. So what works? Okay, -3 and +2. Both negative? Yes, both are positive. Very good. All right, so as I said, we would put a -3 and -2 here. So what about the first terms, though? Usually I have an x squared here, so I know I can put x and x. What could I put if it's an x to the 6th? X cubed and x cubed. So if I'm treating it like a quadratic, and then I'm looking for factors of the last term that add up to the middle term, but it's not a quadratic. It's a quadratic in disguise. Sometimes this is called, it's in quadratic form. Quadratic form. However, if I was solving this, I would not be able to use the quadratic formula. Just because it's in quadratic form does not mean you can use a quadratic formula. But I can factor it this way. And then, if I was solving, if I had a bridge and was going to 0, going to Sawville, that's it. Those are the easy ones. Okay. All right, let's see if we have another quad in disguise here. First of all, would this be a mini mark or a big mark?
Big mark. Big mark.
Yeah, a big one. So let's see if it's even in quadratic form. Is 3 times -24, I don't know what that is. Well, 72? Are there factors of -72 that add up to a -1? -1 right here? 8, 9, right? We would want the non-negative. So, in place of this -1a squared, I'm going to have to put in 8a squared minus 9a squared. I can't just put 8a and 9a like I've been doing. So I'm having to tweak the quadratic situation. But I'm going to use what they call the same algorithm, use the same pattern. What is that? That is so ugly. Is that just 3A and 4? Yeah, 3. Okay, so then we're going to group. We have 4 of them. We have 4. Group these guys. I can pull an A squared out of the first one. I can pull a -9 out of the second group. I can't find them going anymore. 3. Let's try 3. Then pull an A out. It's got to be just -3. Oh, that worked nicely, because these two are common factors. So we pull out the 3A squared plus 8. And it's left is A squared minus. So we're good? Yes.
Why do we use it on my question?
We could have.
It works the same.
Yes. Yes. It's just if you recognize it as a mini mark, you can jump right to the grouping piece. But if you don't, do a long mark and it works the same. Good question. Just distraction. Okay.
Oh, I agree.
X to the 2y minus 5x to the y plus 4. I'm turning up the heat just a little bit. No, right? Swimming a little slower. All right, first let's recognize this. Is it a mark or a mini mark? It's a mini. Well, that's a good sign. If it's a mini, that'll be a little easier. I'm going to go in and put my 2 grouping things. Now let's think about this. What times what? I'm going to have x as a base. X to what power times x to another power will give me x to the 2y power. I'm going to put a y and a y here. What do I do to those exponents when I have a common base and I'm multiplying? Add them. Well, y plus y is 2y. I keep the base of x, and I'd add the exponents and get 2y. Not too bad. Are there factors of 4 that add up to -5? Factors of 4 that add up to -5, -4, -1. -4, -1. What's wrong with it? Not so bad. So don't freak out just because you see something a little different. Let's try this one. X plus 3 squared minus 6 x plus 3 plus 8. Okay, I'm going to do a little substitution here to make this easier. You can go in here and say, you know what, I'm going to let plain x be x plus 3. And then every place I see an x plus 3, I'm going to stick in an x at first, work it out, and then at the very end, stick back an x plus 3. Matter of fact, let's not call it x. Let's call it a. Let a be x plus 3. So I won't get my x's mixed up. Well, if that were true, then this whole x plus 3, I'm going to put an a in its place. This whole x plus 3, I'm going to put an a in its place. Oh, that feels much better. I can handle that. So, mini mark for big mark. Mini. So I can go in this with an a and an a. factors of 8 that add up to -6. -2, -4. Add that all together. -2, -4. Oh, wait. A is not really an A, it's an x plus 3. So what I really have, instead of A, this was an x plus 3 at the beginning. And then I'll have minus 2. This A is really an x plus 3. And then minus 4. So my final answer will be minus 2 is 1. So x plus 1 times x minus 2. That's my final factor. Again? So sometimes you have to, look at them like quadratics, but they're in disguise. This one is certainly in disguise because we have another variable here. This one is in disguise because we have a binomial where we usually just have a single binomial. And that's it. So here's what we're going to do. I'd like for you to do, I'd like for you to do these first 5. And then come up and get them checked for me. You can just do them in your notes if you want. They come up to me, let me check them real quick, make sure you're on the right track, and then you can start your homework after that. Okay?